Here, and this is the 1994 AIME Prom 13. Here's a view of this prom. X to the 10th plus 13x minus 1 to the 10th is equal to 0 has 10 complex roots, which is obviously trivial by the fundamental theorem of algebra. If these are the roots where the bar denotes complex conjugation, find the value of this thing over here. Okay, so this is kind of daunting. So let's start first by finding the roots of this thing. X to the 10th plus 13x minus 1 raised to the 10th is equal to 0. Well, first thing I can do is, what I'm not going to do is I'm not going to expand 13x minus 1 raised to the 10th and hope for something convenient to happen, because that's just way too much work. Instead, I'll just do x to the 10th is equal to negative 13x minus 1 raised to power 10, right? And then if we divide by both sides by negative 13x minus 1 raised to power 10, we get, and then if we if we pull out the 10th power on the other side, we get x over 1 minus 13x raised to power 10 is equal to 1, right? 13x minus 1. Yep, that looks good. Alright, so now how do we solve this? This looks a tiny bit simpler, but not too much. But how would we solve this? Well, we're raising something to the 10th, and that equals 1. That should remind you of the roots of unity, right? So let's actually make this simpler by substituting x over 1 minus 13x is equal to t. So we have x is equal to t minus 13xt, or 13xt plus x is equal to t. And then solving gives us x is equal to t over 13t plus 1, right? X is equal to t over 13t plus 1. Okay, and then now let's also parallel solve t to the 10th is equal to 1. This is something we do know how to do. This is just e to the 2 pi ki by 10, which is equal to e to the pi ki over 5. 4, 0, k, and then 9. Okay, great. So now we know that our roots are going to be of the form e to the pi ki over 5 over 13 times e to the pi ki over 5 plus 1. Alright, good. So we now know that the roots are of this form, and what we want to do is calculate this 1 over something x1 times x1 conjugate, right? So this becomes 1 over x1 times 1 over x1 conjugate. And then now let's see if we can simplify this and see if something convenient happens. So taking this gives us 13 times e to the pi ki over 5 plus 1 over e to the pi ki over 5 times, and then 1 over x1 conjugate. x1 conjugate will just be this thing, but like putting conjugate bars over this, and then times, if we were to do this, this would give us 13 times e to the pi ki over 5 conjugate plus 1 over e to the pi ki over 5 conjugate. Okay, now from here, what do we do? Oh yeah, and I could have just used that t is equal to this is equal to t, right? So that would have been much more simpler. So we know this is t. So what's happening over here is we're multiplying something with magnitude 1 with its conjugate. So we know w conjugate for some complex number w is equal to modulus of w squared. And since these are simply roots of unity, this becomes 1. How about this one? Same thing over here. If you multiply this by this, you get 1. And then how about this? 169 plus 71, which is 170 plus 13. And then this is t plus t conjugate, right? Yeah. So it evaluates to this. Just make sure I did everything correct. Yep, that looks good. So it evaluates to this, huh? Now that's for each. So we have 10 complex roots, right? R1, R2, R3, R4, and R5 and their respective conjugates. Let's try to pair the stuff together, right? The t's and the t conjugates together. So for, how about e to the 0 pi I over phi? What does that pair with? That pairs with, that conjugate pair will be simply e to the phi pi I over phi, right? For obvious reasons. And then e to the pi I over phi, that conjugate pair will simply pair to e to the 6 pi I over phi. Because just take this for example. This will be cosine 6 pi over phi plus I sine 6 pi over phi. And then this will be cosine pi over phi minus I sine pi over phi, which is basically the conjugate of this. Alright? And then we can actually go on, and then we get e to the 4 pi I over phi will pair with e to the 9 pi I over phi. Great. So we've paired all our 10th roots of unity with their respective conjugate pair. That's great. So now if we sum over this, since we're doing this 5 times, this gives us 850 plus 13 times t plus t conjugate, but if you notice, this will actually just, if we sum up these things over here, we box them up, we actually get 0, right? So this is 0. So the answer is 850, and we are done.